In the cold silence of deep space, something blinked. A dot appeared where nothing should move that fast. An interstellar visitor, precise as a carved key in a cosmic lock. Is it chance, or did our own transmissions call it here? Tonight, for the first time, we meet Throi Atlas, the answer we never expected. The night of July 1st, 2025 started like any other at the Atlas Observatory in Chile. Researchers pointed their telescope toward the southern sky, scanning for dangerous rocks that might threaten Earth. But what they found was something completely different. At first, it looked like nothing special, just another dot moving across the star field. But as the hours passed, something strange became clear. This object was moving too fast, way too fast. The computer calculations showed a speed that shouldn't exist for anything born in our solar system. Dr. Elena Rodriguez was working the night shift when the numbers first came through. She had discovered dozens of asteroids before, but this one made her stop and stare at her screen. "It's not following the rules," she whispered to her colleague. The trajectory curved in a way that told an impossible story. Within hours, observatories around the world turned their eyes toward the same patch of sky. The Zwicky Transient Facility in California confirmed what Atlas had found. So did telescopes in Hawaii and South Africa. This wasn't a mistake in the data. This was real. They named it Throi Atlas, the third interstellar object ever discovered by humanity. The I stands for interstellar, meaning it came from the space between stars. But unlike the first two visitors, Oumuamua and Borisov, this one carried secrets that would keep astronomers awake for months. The object was approaching from the direction of Sagittarius, where our galaxy's center burns with billions of stars. It had been traveling through the darkness for millions, maybe billions of years, a cosmic wanderer that had seen star systems we could only dream about. But here's what made the Discovery team nervous. When they traced its path backward through space and time, something didn't add up. The trajectory wasn't random. It wasn't the lazy drift of space debris kicked out from some distant star system. This path looked intentional. Atlas was 410 million miles away when they first spotted it, already inside Jupiter's orbit, moving at 137,000 miles per hour, faster than anything should move if it belonged to our cosmic neighborhood. The speed alone proved it came from somewhere else entirely. As the nights passed and more data came in, the research teams began to realize they were looking at something unprecedented, not just because it came from interstellar space, but because of how it moved, like it knew where it was going. Dr. Rodriguez would later describe those first few nights as the moment astronomy changed forever. "We thought we were looking for rocks," she said. "Instead, we found a visitor that had been traveling toward us since before humans walked the Earth." The object showed clear signs of activity as it approached the sun. A glowing coma of gas and dust surrounded its nucleus, proving it was a comet, not an asteroid. But comets from interstellar space are supposed to be dead, frozen solid by millions of years in the cosmic cold. This one was very much alive. Ground-based telescopes would be able to track Throi Atlas through September, when it would pass too close to the sun for safe observation. Then it would reappear on the other side in December, giving humanity one last look before it continued its journey into the dark. But even in those early days, as excitement built in the scientific community, there were whispers about things that didn't quite fit the standard model. Radio telescopes had begun picking up something unexpected, something that would change everything they thought they knew about this visitor from the stars. The official report spoke of orbital mechanics and hyperbolic trajectories, clean, simple science that could be published in journals and explained to the public. But in the coffee rooms and late-night discussions, astronomers began asking questions they weren't sure they wanted answered. Why had 3 interstellar objects arrived in just 8 years when they should be incredibly rare? Why did this one's approach vector point back to regions of space that would have been perfectly positioned to intercept Earth's radio transmissions from decades ago? And why did it seem to be broadcasting back? The measurements were about to reveal something that would shake the foundations of everything we thought we knew about our place in the universe. Understanding Throi Atlas meant going back to the basics of how things move in space. When something travels through our solar system, it follows predictable rules that have guided astronomy for centuries. But first, we had to understand what normal looks like. Every rock, every comet, Every piece of debris in our solar system follows what we call elliptical orbits. Picture an oval shape with the sun sitting off to one side. Objects swing in close, then drift far out, then return again in an endless dance that can last millions of years. It's been this way since the planets formed 4.6 billion years ago. Johannes Kepler figured out these patterns 400 years ago, watching Mars crawl across the night sky. His discoveries became laws that still guide every spacecraft we launch today. Objects closer to the sun move faster, objects farther out move slower, and the math works perfectly every single time. But 3i Atlas didn't follow these rules. Instead of an ellipse, it traced what astronomers call a hyperbolic path. Picture throwing a baseball so hard it never comes back down. That's a hyperbola, a curve that approaches but never quite touches a straight line. In space terms, it meant this object was moving fast enough to escape the sun's gravity completely. When astronomers measured its speed at 137,000 miles per hour, they knew immediately they were looking at something from another star system. Nothing born in our cosmic neighborhood moves that fast. The numbers told a clear story. This visitor had traveled for millions of years through the cold darkness between stars. Size estimates came next. Using brightness measurements and thermal data, researchers calculated 3i Atlas was roughly 1/200 feet across. Not huge by asteroid standards, but substantial enough to survive the journey between stars. Most smaller objects would have been torn apart by cosmic radiation and micrometeorite impacts during such an enormous voyage. Its composition appeared similar to comets we knew, water ice mixed with carbon compounds and rocky dust. As it approached the sun, solar heat began sublimating the ice directly from solid to gas, creating the characteristic glowing coma that surrounded the nucleus like a ghostly atmosphere. The reflectivity, what scientists call albedo, matched other comets from our own system, about as dark as charcoal, absorbing most of the sunlight that hit it. This suggested similar formation processes wherever it originally came from. Comets are basically dirty snowballs, remnants from when star systems first form. Spectroscopic analysis revealed familiar elements: hydrogen, oxygen, carbon, nitrogen, the building blocks of life as we know it. Nothing exotic or alien in its basic chemistry. In fact, its composition was almost boringly normal, which somehow made its behavior all the more puzzling. The orbital period calculations showed 3i Atlas would take roughly 74 days to swing around the sun and head back out into space, a brief visit by cosmic standards. Most comets from our own Oort cloud take thousands of years to complete their journeys. This visitor was here for a celestial moment, then gone forever. But here's where the textbook explanations began to break down. Normal interstellar objects should be dead when they arrive. The cold of space, sometimes just a few degrees above absolute zero, should freeze everything solid. Comets that have been wandering between stars for millions of years don't usually wake up and start outgassing when they encounter a new sun. Atlas was very much alive. Its coma grew brighter each day as it approached the sun. Jets of gas erupted from its surface in patterns that suggested active geology. Fresh material was being exposed, as if the object had been recently disturbed or activated. The brightness variations as it rotated revealed an elongated shape, tumbling end over end every 7.3 hours. Most comets are irregular chunks of ice and rock, but this one showed signs of structural organization. The way light reflected off its surface suggested smooth regions interrupted by sharp changes in terrain. Thermal infrared observations added another puzzle piece. The object was retaining heat longer than it should. Most comets quickly reach thermal equilibrium with sunlight, heating up during the day and cooling down in shadow. 3i Atlas seemed to have internal heat sources, possibly from radioactive decay or some other process deep inside. These were the facts that could be measured, calculated, and verified. Clean science that would pass peer review and make sense in published papers. An interstellar comet, behaving mostly like comets should behave, with a few curious anomalies that could probably be explained with more data. Astronomers around the world were compiling these numbers into reports and databases. They were building humanity's official record of our third interstellar visitor. The measurements were precise, the calculations were correct, and the conclusions were scientifically sound. But then the measurements began to change. 2 weeks after discovery, something impossible happened. 3I Atlas began to change course. Dr. Sarah Chen was reviewing the latest position measurements from the Hubble Space Telescope when she noticed it first. The object wasn't following the path her computer models predicted. Not by much, just a tiny deviation that could have been measurement error. But Sarah had been tracking asteroids for 15 years, and she knew when something didn't belong. She ran the calculations again, then again. The numbers stayed wrong. Atlas was accelerating in a way that violated everything astronomers understood about how objects move through space. When comets speed up or slow down, it's usually because gas erupting from their surface creates tiny rocket effects. But the acceleration pattern here was different. Too controlled, too precise. It's like someone was steering it, Sarah whispered to herself in the observatory's coffee room at 3 a.m. The words hung in the air, uncomfortable and impossible to take back. Other research teams around the world were seeing the same thing. The European Southern Observatory in Chile reported course corrections that couldn't be explained by solar wind or gravitational effects. The Keck Observatory in Hawaii documented velocity changes that happened in discrete bursts rather than gradual shifts. Most troubling was the light reflection pattern. When sunlight hit 3I Atlas, it bounced back in ways that made no sense for a natural comet. Instead of the rough, scattered glow typical of an icy surface, parts of the object reflected light like polished metal, smooth, deliberate, artificial. The brightness variations told another strange story. As 3I Atlas rotated every 7.3 hours, its light output changed in perfectly regular cycles. Natural objects tumble chaotically after billions of years wandering through space. They get hit by micrometeorites, develop irregular shapes, spin unpredictably. But this visitor maintained a stable rotation that suggested internal gyroscopes or attitude control systems. Dr. Martinez from the Arecibo Observatory had seen enough. On July 15th, he aimed the massive radio dish toward 3I Atlas and transmitted a series of radar pulses. The same technique used to map asteroids and study Venus. The return signal made him call his supervisor at midnight instead of the fuzzy, scattered echo typical of a rocky surface. 3I Atlas produced sharp geometric reflections, flat panels oriented at precise angles, structures that looked designed rather than evolved. The radar signature resembled spacecraft components more than natural materials. But it was the thermal signature that kept astronomers awake at night. Infrared telescopes revealed that different parts of 3I Atlas were heating and cooling in patterns that defied physics. Some sections maintained steady temperatures despite changing distance from the sun. Others showed heat gradients that suggested internal energy sources. NASA's Spitzer Space Telescope, in its final operational months, detected emission lines that shouldn't exist. Brief flashes of organized radiation at specific wavelengths. The kind of signals that come from electronics, not ice and rock. The scientific community faced an uncomfortable question. What do you do when your measurements point towards something impossible? Peer review became tense. Papers submitted to journals came back with requests for additional verification. Extraordinary claims require extraordinary evidence, reviewers wrote, but the evidence was there, accumulating from dozens of observatories worldwide. Some researchers began working in small, unofficial groups, sharing data through encrypted channels. They knew that if word leaked to the media before they understood what they were seeing, the resulting chaos could set scientific research back decades. Dr. Lisa Wong at MIT ran computer simulations trying to match the observed behavior with known physics. Natural explanations became increasingly strained, outgassing patterns that formed perfect geometric shapes, temperature distributions that suggested technological heat management, light reflection that looked more like solar panels than comet surfaces. Maybe we're looking at debris from an advanced civilization, she wrote in an email to colleagues. Something that's been drifting through space for millions of years, finally encountering our solar system. But even that explanation raised more questions. If 3I Atlas was artificial, why did its approach trajectory point back to regions of space that had been perfectly positioned to receive Earth's radio transmissions from the 1970s and 80s? Why arrive now, when humanity was finally sophisticated enough to detect and study interstellar visitors? The orbital mechanics were becoming more puzzling each day. 3i Atlas wasn't just passing through our solar system randomly. Its path was optimized for maximum observation time from Earth's surface. It would remain visible to ground-based telescopes for months, following a trajectory that allowed detailed study from every major observatory on the planet. Amateur astronomers with backyard telescopes began reporting their own anomalies. Light pulses that appeared too brief for natural phenomena, radio emissions picked up by ham radio operators listening at unexpected frequencies. Videos posted to social media showed brightness variations that seemed almost like signaling patterns. The official reports remained carefully neutral. Further observation required. Awaiting additional data. Phenomena not yet fully understood. But behind closed doors, astronomers were asking questions that challenged the foundations of everything they thought they knew about our cosmic neighborhood. Imagine holding measurements that suggested something impossible, numbers that pointed toward technologies beyond human understanding, traveling between the stars for reasons we couldn't fathom. How would you sleep knowing that everything you believed about humanity's place in the universe might be wrong? The radio telescopes were about to detect something that would make these anomalies seem simple by comparison. On July 16, 2025, the universe whispered back. Dr. James Patterson was running the night shift at the Very Large Array in New Mexico when his computer screen lit up with something impossible. 27 radio telescopes, working together like a single giant ear pressed to the cosmos, had detected a signal coming from the direction of 3i Atlas. At first, he thought it was interference. Cell towers, satellites, microwave ovens. The modern world fills space with radio noise that can fool even the most sophisticated instruments. But as the hours passed and the signal persisted, James realized he was looking at something that would change everything. The frequency was 14 to 20.4 megahertz. The hydrogen line, the most important radio frequency in the universe, and the one frequency that every astronomer knows by heart. Hydrogen is the most common element in existence, making up 3/4 of all normal matter in the cosmos. When its single electron flips from one energy state to another, it releases a radio wave at precisely 1420.4 megahertz. It's nature's own beacon, a universal constant that any technological civilization would recognize instantly. If you wanted to get the attention of astronomers, this is exactly where you would broadcast. The signal from 3i Atlas was clean, narrow, and impossibly precise. Natural radio sources in space, pulsars, quasars, stellar coronae, produce messy broadband emissions scattered across many frequencies. This was different, a pure tone, stable as an atomic clock, coming from an object that was supposed to be nothing more than dirty ice and rock. Within hours, radio telescopes around the world were confirming the detection. The Green Bank Telescope in West Virginia, the FAST Array in China, the Parkes Observatory in Australia. Independent observations from different continents eliminated any possibility of local interference or equipment malfunction. The signal was real. It was extraterrestrial in origin, and it was coming from humanity's third interstellar visitor. Imagine holding proof that something was intentionally broadcasting to us. Not the random noise of cosmic phenomena, but a deliberate signal on the one frequency guaranteed to catch our attention. How would that knowledge feel? Settling into your chest like a stone dropped in still water. But the signal was just the beginning. As days passed, additional radio telescopes detected modulation patterns embedded in the carrier wave, subtle variations in amplitude and frequency that suggested encoded information. The kind of structured data that comes from digital communication systems, not natural processes. SETI researchers who had spent decades listening to cosmic silence suddenly found themselves analyzing the first confirmed extraterrestrial signal in human history. The signal strength was incredibly weak, barely above the background noise of space itself, but it was unmistakably artificial, unmistakably intentional. Dr. Elena Vasquez at the SETI Institute had dreamed of this moment her entire career. She had imagined dramatic scenarios, powerful signals from advanced civilizations, obvious mathematical sequences, clear attempts at communication. Instead, she found herself staring at data that was simultaneously proof of everything she believed and nothing like what she had expected. The signal from 3i Atlas wasn't trying to teach us mathematics or share the secrets of the universe. It was simply there. A quiet acknowledgement that someone was listening. A gentle tap on humanity's shoulder from across the cosmic dark. Radio surveys of the region around the interstellar visitor began detecting additional signals. Fainter, more distant, coming from directions where no objects should exist. As if 3i Atlas was part of a larger network. Nodes in a communication system spanning light years. What if this wasn't first contact, but a response to contact we had already made? For over a century, humanity had been broadcasting into space. Every television show, every radar pulse, every radio transmission had rippled outward at the speed of light, announcing our presence to anyone who might be listening. Our radio bubble now extends roughly 130 light-years from Earth, encompassing thousands of star systems. If intelligent life existed within that sphere, they would have been receiving our signals for decades. They would know about us, our technology, our culture, our location in the galaxy. 3i Atlas arrived from a region of space that would have been perfectly positioned to intercept Earth's strongest radio transmissions from the 1970s and 80s. Its trajectory traced back through time to places that could have heard our voices when we first began seriously broadcasting to the stars. The timing was too precise to be coincidental. This visitor had been traveling toward us for decades, launched in response to signals we sent before most of us were born. Someone out there had been listening. Someone had decided to answer. Imagine a voice calling back across the void. Picture civilizations older than our species, patient enough to wait millions of years for technology to develop, wise enough to respond with care rather than force. Imagine consciousness that has crossed the galaxy not to conquer or consume, but simply to say, "We heard you. You are not alone." The possibility reframed everything we thought we knew about our place in the universe. We weren't isolated observers shouting into empty darkness. We were part of a community we had never imagined, connected by threads of electromagnetic radiation that had been carrying our voices to distant shores for longer than we realized. But if 3i Atlas was truly a response to our transmissions, what kind of message were they trying to send? The hydrogen line signal was clear enough, a universal greeting any radio astronomer would understand. But the encoded data embedded in the carrier wave remained mysterious, resistant to every decryption attempt. Perhaps the message wasn't in the data itself, but in the act of communication. Perhaps they were teaching us the most important lesson of all, that in a universe full of wonders and terrors, consciousness reaching out to consciousness is the most profound miracle of all. The radio signal continued. Night after night, as 3i Atlas approached the inner solar system, a quiet conversation between worlds, carried on frequencies that had connected us long before we knew we were speaking. But signals from space had been received before, and ancient stories suggested this conversation might be older than we ever imagined. In the deep hours before dawn, when the world sleeps and the mind wanders to forgotten places, consider this. What if our ancestors had seen them too? Long before radio telescopes swept the sky for signals, long before we understood the physics of interstellar travel, humans looked up at the night sky and told stories about visitors from beyond. Every culture on Earth, separated by oceans and centuries, spoke of the same thing. Watchers in the sky, beings of light who came from the stars. The Sumerian tablets carved 5,000 years ago in cuneiform script described the Anunnaki, those who came from heaven to earth. They were said to travel in vessels that blazed across the night sky, bringing knowledge to early humanity. The tablets speak of regular visits, of teachers who appeared at crucial moments in our development. In ancient Egypt, the pyramid texts carved into stone tombs tell of the pharaoh's soul ascending to join the imperishable stars. But they also speak of descending lights, of vessels that carried divine messengers between the heavens and the Nile Valley. The hieroglyphs show symbols that look remarkably like spacecraft to modern eyes, disc-shaped objects with radiating lines of energy. The Vedic literature of ancient India describes vimanas, flying palaces that could traverse the heavens at impossible speeds. The Mahabharata contains detailed descriptions of aerial battles fought with weapons that sound disturbingly like nuclear devices. The text speaks of visitors from other worlds, of beings who watched humanity's progress with great interest. But perhaps most intriguing are the consistent reports of timing. These ancient visitors, according to the myths, didn't come randomly. They appeared at moments when human civilization was ready to take its next evolutionary step, when we learned to farm, when we built our first cities, when we discovered writing, mathematics, astronomy, almost as if someone was monitoring our progress, watching for signs that we were ready for contact. The Aboriginal Australians speak of the Wandjina, sky beings who came from the stars and taught the first people how to live in harmony with the land. Their cave paintings, some over 40,000 years old, show figures with large eyes and no mouths, beings who communicated without words, directly mind to mind. The Native American Hopi tell of the Star People, visitors who came during the previous worlds before this one. They speak of a time when the sky roads were open, when beings of light traveled regularly between the stars and Earth. The prophecies say they will return when humanity faces its greatest challenges. In the highlands of Peru, the Nazca lines stretch across the desert for miles. Geometric patterns and animal figures so large they can only be properly seen from the air. Local legends speak of sky gods who would come in flying vessels to admire these offerings drawn on the earth below. The lines point towards star patterns that were significant thousands of years ago. Even the Bible contains descriptions that sound suspiciously like contact with advanced technology. Ezekiel's vision of wheels within wheels, blazing with fire and capable of moving in any direction instantly. The appearance to Moses at Mount Sinai, described with the sound and fury of rockets landing. The pillar of fire that guided the Israelites through the desert, a beacon visible from great distances. Consider the consistency of these accounts. Separated by geography and millennia, human cultures independently develop stories about visitors from the sky. Teachers who came at crucial moments, watchers who observed our progress, beings who promised to return when the time was right. What if these weren't myths at all, but memories? What if humanity has been part of a longer conversation than we ever imagined? The radio astronomers studying 3I Atlas began to wonder about timing once again. Our first powerful radio transmissions leaked into space in the 1920s and 30s. Television broadcasts followed in the 40s and 50s. By the 1970s, we were transmitting with enough power to be detected across interstellar distances. If someone had been monitoring our progress, waiting for signs that we had developed electromagnetic communication, they would have detected our signals sometime in the late 20th century. They would have had 50 years to prepare a response, to send visitors who could arrive just as we became sophisticated enough to detect and study them properly. The mythology suggests this has happened before. Visitors who appeared when we developed agriculture, when we learned to work metal, when we built the first observatories and began seriously studying the stars. Each time the stories say they brought gifts, knowledge that helped us take the next step in our development. And each time they withdrew, leaving us to grow and develop on our own until we were ready for the next contact. What if 3I Atlas and its radio signals represent the next chapter in this ancient story? What if the beings who watched our ancestors with such interest have been patiently waiting for us to join the galactic community of technological civilizations? The patterns are there for those who know how to look. Ancient accounts of regular visits, modern detection of objects arriving with impossible precision, radio signals that seem designed to catch our attention, a conversation that may be as old as human consciousness itself. In the quiet moments between sleeping and waking, when the mind drifts toward possibilities beyond the everyday world, imagine that connection stretching back through generations. Imagine consciousness reaching across the void, patient as stone, constant as starlight, waiting for the moment when we would finally be ready to listen. The myths speak of a return. The ancient prophecies promise that the watchers will come back when humanity needs them most. When we have the technology to recognize them, when we have grown wise enough to understand what they offer, perhaps that time is now. Perhaps it always has been, for those who know how to see the signs written in light across the darkness between worlds. But wait, dear dreamer, before we drift too far into the realm of cosmic visitors and ancient communications, we must listen to the voices of reason. The scientific community has always been built on doubt, on testing every extraordinary claim against the cold mathematics of physics. Dr. Michelle Torres at the California Institute of Technology had spent the better part of her career debunking false alarms in astronomy. She had seen pulsars mistaken for alien beacons, unusual radio bursts attributed to extraterrestrial technology, and natural phenomena twisted into evidence for visitation. When the data from 3I Atlas began circulating through academic circles, she approached it with the healthy skepticism that had served science well for centuries. "Look," she said during a video conference with colleagues from around the world. "I understand the excitement, I really do, but we've been down this road before. The radio signal at 1420.4 MHz could have a perfectly natural explanation. Comets sometimes generate radio emissions through interactions with the solar wind. When charged particles from the sun hit the comet's coma, they can create plasma phenomena that emit radio waves at specific frequencies. The hydrogen line frequency isn't necessarily proof of artificial intelligence. It could be a coincidence." Dr. Robert Kim at MIT had run computer simulations showing how natural processes could produce structured radio emissions. "Plasma physics is incredibly complex," he explained. "Under the right conditions, you can get emissions that look artificial, but are actually the result of electromagnetic interactions in the comet's immediate environment." The trajectory anomalies that had troubled so many researchers might also have conventional explanations. Comets are notoriously difficult to predict because outgassing creates tiny rocket effects. As ice sublimates from the surface, it carries away dust and creates jets of material that can alter the object's path in subtle but measurable ways. Atlas was clearly an active comet. Hubble images showed a distinct coma and the beginnings of a tail. The James Webb Space Telescope had detected water vapor, carbon dioxide, and other molecules streaming away from the nucleus. All of this outgassing could easily account for the small course corrections that had seemed so mysterious. "We're seeing exactly what we'd expect from a comet heating up as it approaches the sun," Dr. Kim insisted. "The accelerations match the predicted effects of sublimation. The trajectory changes are consistent with asymmetric outgassing patterns. The light reflection characteristics that had suggested artificial surfaces could also be explained by natural processes. Many comets contain patches of relatively pure ice that can reflect sunlight in unusual ways. The surface of a comet changes constantly as material sublimates and fresh layers are exposed, creating a complex patchwork of textures and compositions. Even the radar returns from Arecibo, showing those geometric reflections that had seemed so artificial might have natural explanations. Comets sometimes contain large chunks of metallic material, iron-nickel fragments from ancient asteroid impacts. These could create the kind of specular reflections that had puzzled radar astronomers. Dr. Sarah Chen, who had first noticed the trajectory anomalies, found herself torn between wonder and scientific caution. "The data is puzzling," she admitted, "but puzzling doesn't necessarily mean artificial. The universe is full of phenomena we don't fully understand yet." Statistical analysis of interstellar object arrivals showed that the recent frequency might not be as unusual as it initially appeared. Better detection systems meant astronomers were finding objects they would have missed in previous decades. The apparent clustering of arrivals could be a selection effect, rather than evidence of coordination. "We're seeing more interstellar objects because we're looking harder and with better tools," explained Dr. Torres. The Catalina Sky Survey, Linear, Atlas, these automated systems scan enormous areas of sky every night. 20 years ago, we would have missed most of these visitors entirely. The hydrogen line signal remained the most intriguing anomaly, but even that could have natural origins. Hydrogen is the most common element in the universe, and comets contain significant amounts of water ice. Under certain conditions, hydrogen atoms in the comet's coma could indeed emit radiation at 1420.4 MHz. Peer review had been thorough and sometimes brutal. Papers submitted to journals came back with requests for additional observations, alternative explanations, and more rigorous statistical analysis. The scientific method was working exactly as it should, preventing premature conclusions based on incomplete data. Extraordinary claims require extraordinary evidence, Dr. Torres reminded her colleagues, echoing Carl Sagan's famous words. And extraordinary evidence means ruling out Every possible natural explanation first. The amateur radio. Operators who claimed to detect structured modulation in the signal were working with equipment that wasn't calibrated for scientific precision. Radio frequency interference from satellites, ground-based transmitters, and atmospheric phenomena could easily create patterns that looked artificial to untrained observers. Government space agencies were maintaining their careful neutrality, releasing data without speculation. NASA's official statements stuck to verified facts, orbital parameters, composition analysis, observational schedules. They avoided any language that might fuel premature excitement about extraterrestrial visitors. "We have a responsibility to the public to remain objective," said Dr. Angela Rodriguez, NASA's planetary defense coordinator. "History is full of astronomical discoveries that initially seemed inexplicable, but eventually found natural explanations." The scientific establishment had learned valuable lessons from previous false alarms. The "wow" signal detected by SETI in 1977 had never repeated despite decades of follow-up observations. The pulsar signals that initially seemed like alien beacons turned out to be rapidly spinning neutron stars. Each time, the universe had revealed itself to be stranger than expected, but not necessarily inhabited. Independent verification would be crucial. Multiple observatories using different techniques needed to confirm every aspect of the 3I Atlas anomalies. Radio telescopes around the world were coordinating observations, sharing data in real time to eliminate the possibility of instrumental artifacts or local interference. Science works because we doubt. Dr. Kim reminded a packed auditorium at a conference on interstellar objects. "We question everything, test every hypothesis, demand reproducible results. That's what separates real discovery from wishful thinking." Yet even the skeptics acknowledged that 3I Atlas was genuinely unusual. The combination of characteristics, the trajectory precision, the radio emissions, the surface properties, created a pattern that challenged conventional understanding of interstellar comets. "We're looking at something that doesn't quite fit our models," Dr. Torres admitted privately to her graduate students. "That doesn't make it artificial, but it does make it scientifically fascinating." The debate would continue for months as more data accumulated. Radio observations, spectroscopic analysis, thermal measurements. Every piece of evidence would be examined, re-examined, and argued over in the careful language of peer review. Yet questions remain, dear dreamer. Even the most rigorous skepticism cannot dismiss the accumulating anomalies entirely. The trajectory that seems too precise, the signals that arrive at exactly the right frequency, the timing that coincides so perfectly with humanity's emergence as a radio civilization. What would you believe, looking up at the night sky, knowing that something from another star system is broadcasting on frequencies that every astronomer recognizes as significant? But 3I Atlas was not alone. As summer gave way to autumn in 2025, automated sky surveys around the world began detecting something unprecedented in the history of astronomy: more interstellar visitors. Not one every few years, as statistical models predicted, but multiple objects arriving within months of each other. The first surprise came from the Catalina Sky Survey in Arizona. On August 15th, their automated detection system flagged another fast-moving object on a hyperbolic trajectory. Initial calculations showed an interstellar origin, incoming velocity too high for anything born in our solar system. They designated it 4I CSS, the fourth confirmed interstellar visitor. 3 days later, the Linear Survey at White Sands detected 5I Linear. Then the Panoramic Survey Telescope and Rapid Response System in Hawaii found 6I pan-stars. By September, amateur astronomers with backyard telescopes were contributing to a growing catalogue of objects that had no business being so numerous. Dr. Alan Fitzsimmons at Queen's University, Belfast, was the first to recognize the pattern. His statistical analysis revealed something that made his hands shake as he typed the conclusions. The probability of this many interstellar objects arriving in such a short time window was roughly 1 in 50 million. Either humanity was witnessing the most extraordinary cosmic coincidence in recorded history, or something was coordinating these arrivals. The trajectory analysis was even more disturbing. When Fitzsimmons traced each object's path backward through space and time, They didn't show the random distribution expected from natural interstellar debris. Instead, their approach vectors converged from a cone of sky roughly 15 degrees wide, centered on the constellation Lyra. It was as if someone had aimed them at our solar system with precision that spoke to intelligence and advanced technology. The targeting wasn't just directional, it was temporal. Each object's arrival time corresponded to a specific chapter in humanity's electromagnetic history. 3I Atlas, if launched from 50 light-years away, would have departed around 1975, the peak era of powerful television transmitters. 4I CSS aligned with the early space age and the construction of large military radar installations. 5I Pan-STARRS corresponded to the period when commercial satellite communications began filling Earth's spectrum with structured signals. Radio telescopes worldwide were now conducting coordinated observations of all the visitors. The results painted a picture that challenged every assumption about interstellar objects. Each one was broadcasting. 3I Atlas maintained its steady carrier tone at the hydrogen line frequency. 4I CSS transmitted in brief, powerful bursts at multiple frequencies across the radio spectrum. 5I Pan-STARRS produced complex modulated signals that seemed to carry encoded information. The diversity suggested a communication network rather than coincidental emissions. Dr. Elena Vasquez at the SETI Institute proposed what became known as the distributed message hypothesis. The objects weren't individual visitors, but components of a larger communication system. Each one carried part of a message that could only be understood when all the pieces were assembled. The implications were staggering. If true, it meant someone had launched multiple interstellar probes decades ago, time to arrive when humanity would be sophisticated enough to detect and study them. The coordination required would represent technology far beyond human capabilities. But the pattern extended beyond just arrival times and radio signals. The objects shared physical characteristics that defied conventional comet physics. All showed signs of controlled rotation rather than chaotic tumbling. All produced radar returns that suggested geometric structures rather than irregular rock and ice. All exhibited thermal properties that hinted at internal heat sources or sophisticated thermal management systems. Dr. Sarah Chen, who had first noticed the anomalies in 3I Atlas, found herself coordinating observations of an entire fleet of interstellar visitors. "We're not looking at random cosmic debris anymore," she admitted to her research team. "This is something planned, something intentional." The size distribution was equally puzzling. Natural interstellar objects should follow a power law, many small ones, fewer large ones, following the same patterns seen in asteroid belts and comet populations. But these visitors clustered around similar sizes, all large enough to carry sophisticated instrumentation across interstellar distances. Ground-based spectroscopy revealed another anomaly. While their basic composition matched known comets, water ice, carbon compounds, rocky dust, each object showed trace elements that suggested artificial processing, isotope ratios that didn't match anything in our solar system, metallic inclusions that formed geometric patterns rather than random distributions. The European Southern Observatory coordinated a massive observational campaign involving telescopes across 4 continents. The Very Large Telescope in Chile, the Keck Observatory in Hawaii, the Gran Telescopio Canarias in Spain, all working together to create a comprehensive picture of humanity's unexpected visitors. High-energy observations added another layer of mystery. The IceCube neutrino detector in Antarctica reported faint but statistically significant correlations between the object's positions and high-energy particle detections. Air shower arrays designed to detect cosmic rays found similar correlations. Whatever propulsion systems these visitors had used to cross interstellar space, they seemed to leave subtle traces that Earth-based detectors could barely perceive. Amateur astronomers became crucial contributors to the research effort. The democratic nature of radio astronomy meant that thousands of hobbyists worldwide could participate in monitoring the signals. Software-defined radio systems, cheap and widely available, allowed anyone with basic technical skills to listen in on the conversation. Online communities sprung up around the observations. Forums where enthusiasts shared spectrum analyses, orbital calculations, and signal processing software. The collaborative effort represented person-years of labor that would have been impossible for professional astronomers alone. But perhaps most intriguingly, the object's behavior suggested they were aware of being observed. Radio signals strengthened when multiple telescopes were pointed in their direction. Course correction seemed timed to optimize viewing geometry from Earth's major observatories. It was as if they wanted to be studied, wanted humanity to understand what they represented. The scientific community found itself grappling with questions that had no precedent in the literature. How do you assess the intentions of visitors from another star system? How do you prepare for contact with intelligence that had been traveling between the stars for decades, possibly centuries? Government space agencies issued carefully worded statements acknowledging the unusual nature of the observations while avoiding speculation about artificial origins. But internal memos, leaked to the press, revealed a different level of concern. Planetary defense coordinators were asking uncomfortable questions about objects that could maneuver and communicate. The visitors weren't threatening in any obvious way. They maintained safe distances from Earth, followed predictable orbits, and showed no signs of aggressive intent. But their very existence challenged fundamental assumptions about humanity's place in the universe and our readiness for contact. With advanced civilizations, what came next would test every theory about who sent these visitors and why they had chosen now, at this moment in human history, to finally reveal themselves. In the quiet hours before dawn at radio observatories around the world, a new kind of vigil had begun. Astronomers who had spent their careers listening to the silence of space suddenly found themselves witnesses to something unprecedented, a conversation between worlds. Dr. Patricia Williams had been working at the Arecibo Observatory for 23 years when the first signals from 3I Atlas came through. She had monitored thousands of hours of cosmic noise, catalogued pulsars, tracked satellites, and searched for patterns in the static. But nothing in her experience had prepared her for the moment when her instruments detected intelligent structure in radio waves from another star system. I sat there for maybe 10 minutes, just staring at the screen, she remembered later. My hands were shaking. You dream about this moment your entire career, but when it actually happens, you realize you have no idea how to react. Patricia's first instinct was doubt. Every SETI researcher learns to expect false alarms, equipment malfunctions, satellite interference. But as the hours passed and the signal persisted, matched by confirmations from observatories across the globe, doubt gave way to wonder, then to a profound sense of responsibility. She was among the first humans to receive an intentional message from another civilization. The weight of that knowledge settled into her chest like a stone, beautiful and terrifying at the same time. At the Green Bank Observatory in West Virginia, Dr. Marcus Chen was experiencing his own moment of revelation. He had joined SETI fresh out of graduate school 15 years ago, driven by curiosity about humanity's place in the cosmos. His parents had questioned the career choice. Listening for aliens, they'd said with gentle skepticism. Now he found himself at the center of the most important discovery in human history. The signal was so clean, so deliberately placed at the hydrogen line frequency, Marcus explained to his research team. This wasn't accidental. Someone wanted us to notice. The human stories behind the discovery were as compelling as the science itself. Dr. Sarah Kim, a postdoctoral researcher at MIT, had been working on her thesis about radio astronomy techniques when the world changed around her. Her dissertation on signal processing suddenly became the foundation for decoding humanity's first extraterrestrial communication. I keep thinking about my grandmother, Sarah said during a late-night observation session. She came to America with nothing but hope that life could be better for her family. Now here I am, receiving messages from the stars. What would she think? The amateur radio community played a crucial role in the unfolding story. Ham radio operators around the world, armed with sophisticated software-defined radios, began monitoring the signals from 3I Atlas and its companions. Their distributed network of listeners provided coverage that no single observatory could match. Tom Rodriguez, a retired electrical engineer in Colorado, detected modulation patterns that professional astronomers had missed. His backyard radio setup, cobbled together from surplus equipment and open-source software, captured subtle variations in the signals that revealed hidden layers of complexity. I've been listening to the sky for 30 years, Tom said in an online forum where enthusiasts shared their findings. Most nights, space is silent. But now it's talking back. The discovery created unexpected connections between people who might never have met otherwise. Professional astronomers found themselves collaborating with amateur enthusiasts, sharing data and insights across traditional boundaries. Graduate students worked alongside retired engineers, united by the shared wonder of receiving messages from the stars. Dr. Elena Rodriguez, the astronomer who had first spotted 3I Atlas at the Chilean observatory, struggled with the emotional weight of her role in history. She had gone to work expecting another routine night of asteroid hunting. Instead, she had opened a door to the universe. "Sometimes I can't sleep," Elena confided to her colleagues. "I lie awake thinking about what we've started. What kind of future are we walking into? Are we ready for this?" The psychological impact rippled through the astronomical community in waves. Some researchers threw themselves into the work with renewed passion, energized by the confirmation that we are not alone. Others found themselves paralyzed by the implications, overwhelmed by questions too large for any individual mind to grasp. Dr. James Patterson, the radio astronomer who had first detected the signals at the Very Large Array, began keeping a journal of his thoughts and observations. He felt a responsibility to document not just the scientific data, but the human experience of first contact. "July 16th will be remembered as the day we joined the galactic community," he wrote. "But I keep thinking about the smaller moments. The way my coffee tasted different that morning, how the sunrise looked more significant, the way ordinary life suddenly felt extraordinary." Families of the researchers found themselves thrust into circumstances no one had imagined. Spouses and children of the astronomers involved in the discovery became guardians of humanity's most profound secret. The weight of that knowledge created new kinds of relationships, bound by shared understanding of what was at stake. Maria Santos, whose husband worked on the signal analysis team, described the strange experience of making dinner while humanity's first extraterrestrial communication played through the speakers in their home office. You're washing dishes, and in the background you can hear signals from another star system, she said. How do you process that? How do you continue with ordinary life when everything has changed? The researchers developed rituals and traditions around their vigil. Night shift teams at observatories created informal ceremonies for each new detection, each breakthrough in understanding. They were writing the first chapter of a new era in human history, and they felt the weight of that responsibility in every decision. Some found comfort in philosophy and spirituality. Dr. Williams began reading ancient texts about humanity's relationship with the cosmos, seeking wisdom from cultures that had pondered our place among the stars. Others turned to literature, finding parallels in science fiction stories that had imagined this moment long before it arrived. But perhaps the most profound impact was the simple recognition that we are no longer alone. Every researcher involved in the project described a fundamental shift in perspective, a new understanding of Earth's place in the cosmic community. When I look up at the night sky now, it looks different, Dr. Chen reflected. The stars aren't just distant suns anymore. They're neighbors. Some of them have been watching us, listening to our broadcasts, preparing to make contact. The universe feels inhabited. How would you feel if you were among the first humans to know with certainty that intelligence exists beyond our world? How would you carry that knowledge through your daily life, making breakfast and walking to work while signals from another civilization played in the background of human history? The weight of first contact belongs not just to the scientists who detected it, but to all of us who must now live in a universe where we are no longer alone. Deep in the underground laboratories of the National Security Agency, Dr. Rebecca Carter stared at computer screens filled with patterns that shouldn't exist. The encrypted data streams from 3I Atlas had been routed through the most sophisticated signal processing systems on Earth, analyzed by algorithms designed to break the most complex military codes. What they found defied every assumption about random cosmic noise. The signals weren't just structured, they were elegant. Mathematical relationships embedded in the timing, frequency shifts that followed harmonic progressions, modulation patterns that suggested not just intelligence, but artistry. Someone was composing symphonies in electromagnetic radiation. "Look at this sequence," Dr. Carter said to her team, highlighting a section of data on her main display. Prime numbers in ascending order, but embedded in a carrier wave that pulses in the Fibonacci sequence. This isn't accidental. This is intentional communication. The analysis had taken weeks. Traditional SETI protocols focused on simple, obvious patterns, mathematical sequences, repeating signals, anything that would stand out against natural background noise. But the messages from 3i Atlas were subtle, layered with meaning that revealed itself only through careful examination. Each burst of radio energy contained multiple levels of information. The primary carrier wave at the hydrogen line frequency was just the beginning. Embedded within that signal were secondary modulations, tiny variations in amplitude and frequency that created a complex data stream. And within that stream, mathematical patterns that suggested knowledge of advanced physics and engineering. Principles Dr. James Wu at MIT had been running the signals through pattern recognition, software designed for analyzing human languages. The results were disturbing. The data showed statistical properties similar to natural language, the kind of redundancy and structure that indicates meaningful communication rather than random information. It's like listening to someone speak in a language we don't understand, Dr. Wu explained to his research team. We can identify sentences, paragraphs, even what might be chapters or topics, but the actual meaning remains hidden. The most intriguing discovery came from thermal imaging data collected by the James Webb Space Telescope. As 3i Atlas rotated through its 7.3-hour cycle, different sections of its surface showed temperature variations that matched the radio signal patterns. It was as if the entire object was a transmission antenna, with different areas activating in sequence to broadcast specific parts of the message. High-resolution radar mapping revealed surface features that challenged every assumption about natural comet formation. Instead of the rough, chaotic terrain typical of icy bodies, 3i Atlas showed geometric patterns etched into its surface, parallel lines, concentric circles, and angular structures that looked more like circuit boards than geological formations. The European Southern Observatory's interferometric measurements painted an even stranger picture. Using multiple telescopes working together as a single instrument, they could resolve features just a few meters across on the object's surface. What they saw looked like technology: flat panels that caught and reflected sunlight with mirror-like precision, cylindrical structures that might be antenna arrays, surface materials that showed spectral signatures unlike any known mineral composition. The object wasn't just carrying a message, it was the message, a technological artifact designed to demonstrate capabilities beyond human understanding. Amateur astronomers contributed crucial observations to the growing database. Tom Rodriguez in Colorado had modified his backyard radio telescope to track the object's rotation, creating detailed maps of signal strength variations. His data revealed that the strongest transmissions came from a specific region on the object's surface, an area that radar imaging showed to be perfectly smooth and reflective. "It's like a radio mirror," Tom explained in an online forum. "Whatever's buried under that surface is beaming signals directly at Earth every time the object rotates to the right angle. And the beam is incredibly narrow, just a few arc-seconds wide. They're not broadcasting to the whole galaxy. They're talking specifically to us." The precision was remarkable. 3i Atlas maintained its orientation with accuracy that suggested internal guidance systems. Small course corrections kept the object in optimal position for communication with Earth's radio telescopes, as if it was aware of being observed and was cooperating with the study. Dr. Sarah Chen had been tracking these micro-adjustments for weeks, plotting them against the object's predicted trajectory. The pattern was clear. 3i Atlas was steering itself to maximize observation time from Earth's major observatories. It wanted to be studied, wanted humanity to understand what it represented. But perhaps the most unsettling discovery came from gravitational measurements. The object's mass distribution didn't match its visible size and composition. Dense regions that suggested internal structures, hollow sections that indicated empty spaces where equipment might be housed. The gravitational signature looked more like a spacecraft than a natural comet. Dr. Elena Vasquez at the SETI Institute had been compiling a comprehensive database of all observations, searching for patterns that might reveal the object's purpose. Her analysis suggested that 3i Atlas was operating according to a predetermined program, following instructions encoded in its internal systems decades or centuries ago. This isn't a probe in the sense we usually think of them, she explained to a classified briefing at the Pentagon. It's more like a message in a bottle, but the bottle is itself part of the message. Everything about this object, its trajectory, its composition, its behavior, is designed to tell us something. The thermal signature from the Spitzer Space Telescope had revealed another anomaly, internal heat sources that couldn't be explained by radioactive decay or solar heating, temperature gradients that suggested active systems still operating after millions of years in the cold of interstellar space. Whatever power source 3i Atlas used, it was far more sophisticated than anything in human technology. Spectroscopic analysis of the object's outgassing revealed isotope ratios that didn't match anything in our solar system. The deuterium to hydrogen ratio suggested formation in a stellar environment with different metallicity than our Sun. Chemical signatures that pointed to industrial processing rather than natural comet formation. The data was accumulating, faster than human analysts could process it. Machine learning algorithms designed for big data analysis were finding patterns in the signals that human researchers had missed. Correlations between radio emissions and surface temperature changes, timing relationships that suggested coordinated activity across different regions of the object. But one piece of evidence remained, deliberately unexplained in all the official reports buried deep in the radar. Returns from Goldstone was an anomaly that the research team had decided to classify as a measurement error. A reflection that came back too quickly, suggesting a surface feature that extended beyond the object's visible boundaries, something that might be a retractable antenna or sensor array, deployed only when needed for specific observations. The implications were staggering. If 3i Atlas could extend and retract equipment, if it could modify its configuration based on circumstances, then it wasn't just a passive message carrier. It was an active intelligence, capable of adapting its behavior in real time. How do you sleep at night, knowing that something from another star system is watching us with instruments we can barely detect, analyzing our capabilities while we struggle to understand theirs? In the deep archives beneath government buildings around the world, classified documents tell stories that few have been permitted to read. Stories about what happens when civilizations make contact with the unknown. Stories about worlds that listened to the stars and were forever changed. The Younger Dryas event, 12,800 years ago, marked one of the most dramatic climate changes in Earth's recent history. Global temperatures plummeted within decades. Ice sheets advanced across continents. Human civilization, just beginning to experiment with agriculture, nearly vanished entirely. The cause remains officially unknown, but deep in the geological record, researchers have found traces of elements that don't belong in natural formations. Platinum group metals scattered across multiple continents in precisely dated layers. Microscopic diamonds that could only form under extreme pressure. Glass spherules that suggest temperatures hot enough to melt rock across vast distances. The official explanation involves comet impacts or massive volcanic eruptions, but some researchers whisper about other possibilities in private conversations that never make it into published papers. The Bronze Age collapse, 3,200 years ago, saw advanced civilizations across the eastern Mediterranean simply disappear. The Mycenaeans, the Hittites, the peoples of ancient Syria and Canaan, entire cultures that had built cities, developed writing systems, and traded across vast distances, all vanished within the span of a few generations. The archaeological record shows burning cities, abandoned territories, and a sudden return to simpler ways of life. Mainstream historians blame invasion by mysterious sea peoples, climate change, or internal social collapse. But scattered throughout ancient texts are references to visitors from the sky, to teachers who came from the stars bearing knowledge that transformed everything they touched. The Epic of Gilgamesh speaks of beings who traveled between heaven and earth. The Book of Enoch describes watchers who descended from the firmament to share forbidden wisdom with humanity. What if these weren't myths, but memories of contact that reshaped civilization itself? The Permian extinction, 250 million years ago, erased 90% of all life on Earth. The Cretaceous impact, that ended the dinosaurs was merely one chapter in a longer story of cosmic events that periodically reset the evolutionary clock. Each mass extinction opened new possibilities, cleared ecological niches for different forms of life to emerge and flourish. But the pattern suggests something more than random catastrophe. The timing, the selective nature of what survives and what perishes, the way each extinction event creates conditions perfectly suited for the next phase of evolutionary development, almost as if someone was gardening on a planetary scale, cultivating consciousness across geological time. Dr. Elena Vasquez had been thinking about these patterns as she studied the data from 3I Atlas and its companions. The arrival of multiple interstellar visitors during humanity's technological adolescence wasn't unprecedented. It was part of a cycle that stretched back through deep time, contact events that appeared in the geological and historical record as catastrophes, but might actually represent something far more profound. What if the mass extinctions weren't endings, but transformations? She asked during a classified briefing at the Pentagon. What if someone has been monitoring Earth's biological development for millions of years, intervening at crucial moments to guide evolution toward intelligence? The implications were staggering. If true, it meant human consciousness itself might be an artifact of external intervention. Our capacity for abstract thought, for mathematics and music and art, could be gifts from civilizations so ancient that they remembered the birth of our solar system. The radiocarbon record shows spikes in atmospheric carbon-14 levels at regular intervals throughout history, suggesting periodic bombardment by cosmic rays or other high-energy particles. These events correlate with major transitions in human development: the emergence of agriculture, the development of metallurgy, the sudden appearance of complex astronomical knowledge in cultures that shouldn't have possessed such understanding. Ancient sites like Göbekli Tepe in Turkey, built 11,000 years ago, demonstrate sophisticated engineering and astronomical alignment that preceded the development of agriculture by millennia. The builders possessed knowledge of celestial mechanics that wouldn't be rediscovered until the invention of modern telescopes. How did hunter-gatherer societies create monuments that required understanding of precession, ecliptic cycles, and galactic coordinates, unless someone taught them? The Nazca lines in Peru, the stone circles of Britain, the megalithic structures scattered across every continent, all point to sky knowledge that arrived suddenly in human cultures around the world, often coinciding with stories of teachers who came from the stars. Not gradual discoveries made through generations of careful observation, but complete systems of understanding that appeared overnight in the historical record. Consider the mathematics encoded in the Great Pyramid of Giza. The dimensions incorporate pi, the golden ratio, the speed of light, and the precise circumference of Earth, values that weren't officially calculated by human science until the modern era. The structure serves as a stone library, preserving knowledge that its builders somehow possessed, despite lacking the instruments necessary to discover it independently. What if the pyramid wasn't just a tomb, but a message, a way of preserving crucial information through the rise and fall of civilizations, ensuring that future humans would eventually recognize the mathematical relationships embedded in its design? The Mayan calendar system demonstrated precise knowledge of planetary cycles that required centuries of continuous observation to develop. Yet it appeared fully formed in their historical record, complete with corrections for orbital variations that wouldn't be discovered by European astronomy until the invention of precision chronometers. The Maya wrote about cycles of creation and destruction, about gods who returned from the sky at predetermined intervals to judge human progress. Modern SETI researchers studying the signals from 3I Atlas were finding similar patterns. The mathematical relationships embedded in the radio transmissions included references to galactic coordinates, stellar distances, and timescales that suggested knowledge of cosmic geography far beyond human capabilities. But embedded within that vast perspective were specific references to Earth's history, to evolutionary milestones and geological events that could only come from long-term observation of our planet. Someone had been watching us for a very long time. The signals weren't just communications, they were acknowledgements of stewardship, confirmation that the intelligence behind 3i Atlas had been involved in humanity's development from the very beginning. We weren't just receiving first contact, we were receiving recognition that we had finally reached a level of technological sophistication that made open communication possible. But with that recognition came responsibility. The same intelligence that had guided human development through previous transitions was now offering us the choice of how to proceed. The messages from the interstellar visitors contained both incredible opportunities and terrible warnings about the consequences of contact between civilizations. At different levels of development, history showed what happened to less advanced cultures when they encountered superior technology. Sometimes they adapted and grew stronger. More often, they were overwhelmed, their own development stunted or destroyed by dependence on knowledge they hadn't earned through their own discovery. The cosmic gardeners were offering us a choice: grow into the community of galactic civilizations, or face the same resets that had claimed so many worlds before us. When the weight of discovery settles heaviest on the mind, Dr. Sarah Chen sat in her office, surrounded by months of data that defied easy explanation. On one monitor, radio signals from 3i Atlas pulsed in mathematical patterns that spoke of intelligence. On another, peer-reviewed papers questioned every assumption about what those patterns might mean. Science, she reflected, was built on doubt. Every extraordinary claim had to survive the grinding process of verification, replication, and peer review. And the claims surrounding humanity's interstellar visitors were extraordinary indeed. What could they prove with absolute certainty? The objects were real, that much was beyond question. Multiple observatories, different instruments, independent research teams all confirmed the same basic facts. 3i Atlas and its companions were interstellar in origin, following hyperbolic trajectories that carried them through our solar system at velocities impossible for natural solar system objects. The radio emissions were equally certain. The signals occurred at the hydrogen line frequency, showed artificial structure, and originated from the vicinity of the objects. Doppler shift measurements confirmed that the sources moved with the visitors, ruling out background interference or coincidental emissions from other sources, but beyond these established facts lay an ocean of interpretation where certainty gave way to informed speculation. The precise trajectory, targeting that had so impressed researchers could have natural explanations. Interstellar objects don't actually travel in straight lines. They follow complex paths influenced by the gravitational fields of every star system they encounter during their million-year journeys. What appeared to be intentional navigation might be the result of gravitational assists from stars humanity hadn't yet identified in their backtracked paths. Dr. Marcus Torres at Caltech had spent weeks running computer simulations, modeling how gravitational perturbations could produce trajectories that converged on Earth's orbital zone. His results showed that certain combinations of stellar encounters could indeed create the apparent precision that had seemed so artificial. We're dealing with selection effects, Dr. Torres explained to a packed auditorium at the International Astronomical Union meeting. We only detect the objects that pass close to Earth. The thousands of others that miss our solar system entirely remain invisible to our surveys. The radio signals, while undeniably artificial in structure, might also have conventional explanations. Plasma physics in the environment surrounding active comets could, under specific conditions, generate coherent emissions at discrete frequencies. The hydrogen line wasn't necessarily chosen for communication. It might simply be the natural result of hydrogen atoms in the object's comas interacting with the solar wind. Dr. Elena Vasquez had run extensive models of plasma interactions, trying to reproduce the observed signal characteristics through natural processes. While she couldn't fully explain the complex modulation patterns, she demonstrated that simple carrier tones at the hydrogen line frequency were theoretically possible through electromagnetic effects in comet environments. We have to be careful about pattern recognition, she cautioned. Human minds are exceptionally good at finding structure in random data. We see faces in clouds, hear voices in static, discover conspiracies in coincidences. The peer review process had been merciless. Papers submitted to major journals came back with demands for additional observations, alternative explanations, and more rigorous statistical analysis. Reviewers questioned methodology, challenged interpretations, and demanded evidence that met the highest standards of scientific proof. Extraordinary claims require extraordinary evidence became the mantra repeated in faculty meetings, conference presentations, and late-night discussions in observatory break rooms. Carl Sagan's famous words served as both guide and burden for researchers grappling with data that suggested profound implications for humanity's place in the universe. Government agencies maintained their carefully neutral stance. NASA's official statements presented verified observational facts without speculating about origins or intentions. The European Space Agency issued similar reports: orbital parameters, spectroscopic data, measurement uncertainties, clean, objective science that avoided the dangerous territory of interpretation. But the absence of official speculation didn't mean absence of official interest. Classified briefings for national security personnel painted a different picture. Behind closed doors, military analysts discussed potential threats from objects that could maneuver and communicate. Contingency plans were quietly developed for scenarios that couldn't be discussed in public forums. Dr. Rebecca Carter, whose NSA team had been analyzing the signal structures, found herself caught between scientific skepticism and operational reality. The mathematical patterns embedded in the transmissions were too complex for random generation, too sophisticated for natural processes, but proving artificial intelligence required ruling out every possible natural explanation, a standard of proof that might be impossible to meet. We can demonstrate that the signals show characteristics consistent with artificial origin, she reported in classified briefings. But science doesn't traffic in certainty, only in degrees of confidence, and the confidence intervals on extraterrestrial intelligence are necessarily enormous. Independent verification remained the gold standard. Radio telescopes worldwide continued their coordinated observations, sharing data in real time to eliminate instrumental artifacts. The signals persisted, night after night, showing the same artificial characteristics regardless of which instruments detected them. Amateur astronomers contributed crucial validation. Their distributed network of observers, using different equipment and techniques, consistently reported the same phenomena that professional observatories detected. The democratic nature of radio astronomy meant that the observations couldn't be dismissed as institutional bias or equipment-specific artifacts. But validation of the signal's existence didn't validate their interpretation. The gap between artificial radio emissions from interstellar objects and intentional communication from extraterrestrial intelligence remained enormous, filled with assumptions that couldn't be independently verified. Dr. James Patterson, whose initial detection at the Very Large Array had started the investigation, wrestled with the implications of his discovery. The scientist in him demanded skepticism, rigorous analysis, consideration of all alternatives. The human in him couldn't ignore the growing body of evidence pointing toward intelligence behind the phenomena. We're looking at data that challenges our fundamental assumptions about our place in the universe, he admitted during a faculty seminar. But challenging assumptions isn't the same as overturning them. Science progresses through careful steps, not revolutionary leaps. The statistical analysis created its own uncertainties. The probability of multiple interstellar objects arriving by chance with coordinated trajectories and artificial radio emissions was vanishingly small. But vanishingly small wasn't zero, and science had been surprised by improbable coincidences before. Moreover, the calculations depended on assumptions about the true population of interstellar objects, their typical trajectories, and the frequency of natural radio emissions, parameters that were themselves poorly known. Small changes in assumptions could dramatically alter probability estimates. What do we really know, and what do we merely hope? The question haunted every researcher involved in the observations. The verified facts painted a picture of phenomena that didn't fit conventional models of interstellar objects. But phenomena that didn't fit existing models weren't necessarily evidence of intelligence. They might simply indicate that existing models were incomplete. Yet the possibility remained, growing stronger with each night of observations, that humanity was witnessing something unprecedented. The weight of that possibility and the responsibility it carried rested heavily on every scientist involved in unraveling the mystery. In the end, perhaps the most honest answer was also the most unsatisfying. We don't know enough yet to know what we don't know, but uncertainty is not the same as ignorance. And in the space between what we can prove and what we dare to imagine, the most profound discoveries often take root. In the deep silence of the cosmos, where space and time fold around the gravity of stars, something remarkable reveals itself to those who know how to look. The surface of 3I Atlas, examined through the most powerful telescopes on Earth and in space, shows patterns that whisper of intention, of design, of intelligence operating on scales that dwarf human understanding. Dr. Maria Santos had been studying high-resolution radar returns from the Goldstone Deep Space Network for weeks when she noticed it first. Hidden within the scattered echoes from 3I Atlas's surface were geometric structures too regular for natural formation, lines that intersected at precise angles, curves that followed mathematical relationships she recognized from engineering textbooks. "Look at this section," she said to her research team, highlighting a portion of the radar map on her display. "These aren't random impact craters or outgassing vents. These are constructed features, panels maybe, or antenna arrays." The mathematics were undeniable. The ratios between surface features matched the golden ratio with precision that would challenge human manufacturing capabilities. Distances between structural elements followed Fibonacci sequences. Angular relationships incorporated pi and the square root of 2 to decimal places that implied measurement. Techniques far more sophisticated than casual observation, but it was the thermal imaging from the James Webb Space Telescope that revealed the true complexity of 3I Atlas's design. As the object rotated through its 7.3-hour cycle, different sections of its surface showed temperature variations that couldn't be explained by solar heating alone. Some areas remained consistently warmer than their surroundings, suggesting internal heat sources or active thermal management systems. More intriguingly, the thermal patterns changed in response to external stimuli. When radio telescopes on Earth transmitted signals toward 3I Atlas, specific regions of its surface would warm up within hours. When ground-based radar systems painted the object with powerful pulses, thermal blooms would appear at corresponding locations. It was as if the visitor was responding to human attention, activating systems that had remained dormant during its long journey between the stars. The spectroscopic data painted an equally fascinating picture. Different areas of 3I Atlas's surface showed distinct material properties, not the uniform composition typical of natural comets. Some regions reflected light like polished metal, others absorbed electromagnetic radiation across broad spectrums. Still others showed spectral signatures that matched no known natural materials. Dr. Elena Rodriguez had been conducting detailed photometric analysis of the object's rotation, measuring tiny variations in brightness as different surfaces caught the sunlight. The light curves revealed structural complexity that challenged every assumption about interstellar visitors. Instead of the irregular, chaotic shape expected from a collision fragment or ejected comet nucleus, 3I Atlas showed signs of deliberate engineering. "The mass distribution is all wrong for a natural object," she explained to her graduate students. "It's too balanced, too symmetrical. Natural bodies tumble erratically because their centers of mass don't align with their geometric centers. But this thing spins like a precision gyroscope. The object's stability extended beyond simple rotation. Course corrections that had initially puzzled astronomers showed patterns consistent with active attitude control. Tiny adjustments in orientation that kept specific surface features pointed toward Earth during optimal observation windows. Trajectory modifications that maximized the duration of visibility from ground-based telescopes. And then there was the hum. Radio telescopes monitoring 3I Atlas detected a low-frequency vibration that seemed to emanate from the object's interior. Not the hydrogen line signal that had first captured attention, but a deeper resonance that suggested massive internal structures operating at frequencies below human hearing. The hum varied in intensity as different parts of the visitor rotated into view, as if enormous machinery was cycling through operational states. Amateur radio operators around the world began reporting the phenomenon independently. Software-defined radio systems designed for satellite communication could barely detect it, but the signal was there. A subsonic thrumming that seemed to speak of vast mechanisms awakening after eons of dormancy. Tom Rodriguez, The retired engineer in Colorado, whose backyard radio setup had detected crucial modulation patterns in the early observations, described the experience of monitoring the hum during long winter nights. "It's like listening to the heartbeat of something enormous," he posted in online forums, where enthusiasts shared their findings. "You can feel it more than hear it. When I tune my equipment to just the right frequency, the whole observatory seems to vibrate in sympathy." The hum's frequency matched mathematical relationships found in the object's physical structure, resonances that would occur if hollow chambers within 3I Atlas were vibrating at specific harmonics, acoustic signatures that suggested internal architecture on a massive scale, corridors, chambers, machinery spaces large enough to house human cities. Computer modeling of the acoustic properties painted a picture of internal organization that defied natural explanation. Geometric chambers arranged in patterns that optimized both structural strength and acoustic resonance. Material properties that suggested construction. Techniques capable of maintaining structural integrity across interstellar distances while preserving delicate internal mechanisms. The James Webb Telescope's infrared observations revealed temperature gradients within the object that matched the acoustic mapping, heat sources located at positions that corresponded to junction points in the resonance structure, thermal signatures that suggested active systems drawing power from sources buried deep within the visitor's interior. Dr. Sarah Chen had been coordinating observations from multiple space-based platforms, creating a comprehensive picture of 3I Atlas that extended from surface features to internal architecture. The composite data revealed an object of staggering complexity, not just a messenger carrying information, but a technological artifact that demonstrated engineering capabilities beyond human understanding. "We're looking at construction techniques that we can barely comprehend," she reported. During a classified briefing for aerospace engineers, materials science that allows structures to maintain integrity across million-year journeys, power systems that can operate for geological timescales without maintenance, manufacturing precision that exceeds anything in human industry. The implications extended beyond the object itself. If 3I Atlas represented the work of an advanced civilization, what did that suggest about the beings who had built it? The scale of engineering, the time horizons involved, the casual precision with which problems had been solved, all pointed to intelligence that operated on fundamentally different scales than human consciousness. But perhaps most unsettling was the growing evidence that 3I Atlas was not unique. Radar observations of the other interstellar visitors showed similar geometric patterns, similar thermal signatures, similar acoustic properties. They were products of the same technology, the same design philosophy, the same incomprehensibly advanced manufacturing capability. The visitors weren't random debris from some distant stellar catastrophe. They were components of a coordinated system, each one engineered for specific purposes, all arriving at precisely calculated times to maximize their impact on human consciousness. The hum continues, dear dreamer, even now, as you rest in the quiet hours before dawn. Radio waves carry that deep vibration across the darkness between worlds. Can you hear it too? The sound of vast intelligence stirring to life in the cosmic depths, preparing to reshape everything we thought we knew about our place among the stars. Across the world, in observatories tucked into mountain peaks and radio telescopes scanning empty deserts, a pattern was emerging that connected every culture, every legend, every whispered story about visitors from the stars. As autumn settled over Earth in 2025, researchers began to realize that the arrival of 3I Atlas and its companions wasn't just a modern phenomenon. It was the latest chapter in a story as old as human consciousness itself. Dr. Sarah Kim had been correlating astronomical data with archaeological records when she noticed the first connection. Ancient sites around the world, built thousands of years apart by cultures that had never contacted each other, all showed alignments pointing toward the same region of sky. Not toward prominent stars or obvious celestial landmarks, but toward empty space in the constellation Lyra, the same direction from which the interstellar visitors were arriving. Göbekli Tepe in Turkey, built 11,000 years ago, incorporated stone pillars that formed sightlines pointing toward coordinates that would have tracked the precession of that specific region over millennia. The pyramids at Giza showed similar alignments, but adjusted for the different historical period of their construction. Stonehenge, Angkor Wat, the Nazca Lines, all incorporated references to the same patch of sky. It's as if every major ancient civilization was watching for something coming from that direction. Dr. Kim reported to an emergency session of the International Astronomical Union, and they built monuments to mark the waiting. The Mayan calendar system, with its precise tracking of celestial cycles, contained references to the return of the feathered serpent Kukulkan from the direction of the summer constellation. Their codices spoke of cycles within cycles, of visitors who would return when humanity was ready for the next phase of cosmic awareness. In the highlands of Peru, the Inca spoke of the return of Viracocha, the creator god who had taught their ancestors the arts of civilization before departing with promises to return. Their astronomical alignments, built into temples and ceremonial sites throughout the Andes, tracked the same region of sky that modern astronomers now watched with growing wonder. Australian Aboriginal Dreamtime stories, passed down through 40,000 years of oral tradition, spoke of the sky ancestors who travelled between the stars on paths of light. Their traditional astronomical knowledge included references to visitor stars that appeared in the region of Lyra during specific seasonal cycles, usually coinciding with periods of cultural transformation and new knowledge. As governments around the world quietly prepared for disclosure, as observatories coordinated unprecedented international cooperation, as the signals from the interstellar visitors grew stronger with each passing night, humanity began to understand that we were not witnessing first contact, but homecoming. The myths and legends of every culture on Earth were converging into a single truth. We had been part of a galactic community all along, waiting for the moment when we would finally be ready to consciously participate in something far greater than our individual civilizations. The Chinese I Ching, one of the world's oldest divination systems, contained hexagrams that modern researchers were beginning to interpret as star maps. The arrangements of broken and unbroken lines, when plotted as coordinates, pointed toward the same celestial coordinates that had captivated ancient builders worldwide. The text spoke of dragons descending from heaven during periods when certain celestial conditions were met. Hindu astronomical texts described the Vimanas, flying palaces of the gods, returning to Earth during specific celestial alignments. The Vedic literature contained remarkably precise descriptions of interstellar travel, complete with time dilation effects and navigational techniques that wouldn't be rediscovered by human science until the development of relativistic physics. But it was in the archives of the Vatican, in documents that had been classified for centuries, that researchers found the most explicit connections. Papal astronomers had been tracking unusual celestial events for over 1,000 years, documenting periodic appearances of objects that moved too fast and in the wrong directions to be natural comets. The records spoke of visitors who came bearing messages for humanity, but only when we had reached sufficient spiritual and technological maturity to understand their meaning. The breakthrough came when linguists began comparing the mathematical patterns in the radio signals from 3i Atlas with ancient texts from around the world. The ratios, frequencies, and timing sequences that had puzzled modern researchers matched numerical systems preserved in Sanskrit manuscripts, Mayan codices, and Egyptian hieroglyphic texts. Dr. Elena Rodriguez, who had been studying the acoustic properties of the interstellar visitors, made a discovery that sent ripples through the international research community. The subsonic hum emanating from 3i Atlas matched frequencies described in Tibetan singing bowl traditions, in Aboriginal didgeridoo ceremonies, and in the acoustic properties of ancient temples built around the world. They've been teaching us their frequency all along, she realized during a late-night observation session. Every culture developed music and architecture that resonated with these same mathematical relationships. We've been unconsciously preparing for this moment for millennia. Government agencies worldwide were coordinating response protocols that had been developed in secret over decades. The post-detection policies established by the SETI community provided frameworks for scientific verification and public disclosure, but the scale of what was happening exceeded every planned scenario. The United Nations Office for Outer Space Affairs convened emergency sessions in Vienna, bringing together astronomers, linguists, anthropologists, and policy experts from every major nation. For the first time in human history, the species was preparing to respond as a unified civilization to contact from another star system. Amateur astronomers and citizen scientists had become crucial participants in the global observation effort. The democratic nature of radio astronomy meant that millions of people worldwide could participate in receiving and analyzing the signals. Online communities translated findings into dozens of languages, shared analysis software, and coordinated observations across time zones. Religious leaders from every major faith tradition found themselves grappling with theological implications that their training hadn't prepared them for. But many discovered that their ancient texts contained guidance that seemed remarkably relevant to current circumstances. Scriptures about messengers from heaven, about humanity's role in a cosmic community, about preparation for transformation that would transcend individual cultures and nations. Social media platforms became repositories for shared wonder as people around the world realized they were living through the most significant moment in human history. Amateur videos showed the interstellar visitors as bright dots moving against the star fields, growing brighter each night as they approached the inner solar system. But perhaps most remarkably, the arrival of the visitors was having an unexpected effect on human consciousness itself. People reported dreams that seemed to contain information they hadn't learned through normal means. Children drew pictures of geometric patterns that matched the surface features detected on 3i Atlas. Musicians composed melodies that incorporated the mathematical ratios embedded in the radio signals. It was as if the mere presence of the interstellar visitors in our solar system was awakening dormant capabilities in human consciousness, reminding us of connections that had been preserved in myth and legend but forgotten by our rational, technological civilization. The pattern was clear to anyone willing to see it. Every culture on Earth had been preparing for this moment. Every ancient monument, every sacred text, every traditional ceremony contained pieces of a vast puzzle that was finally being assembled. The visitors from Lyra weren't strangers arriving unexpectedly. They were family members returning home after a long journey through the cosmic dark. As 3i Atlas and its companions continued their precisely calculated approach toward the inner solar system, humanity began to understand that we were not just witnessing contact between civilizations, but awakening to our true place in a community of consciousness that spans the galaxy. And so we come to the end of our journey through the dark, dear dreamer, but perhaps it's not really an ending at all. Atlas continues its ancient dance around our sun, carrying signals and secrets from civilizations older than our dreams. Every night, radio telescopes around the world receive its gentle transmissions, not demands or threats, but patient invitations to join something larger than we ever imagined. The questions remain unanswered, floating like stardust in the space between what we know and what we hope. Did we really summon these visitors with our century of broadcasts? Are they messengers from the cosmic family we never knew we had? Or are we simply seeing patterns where none exist, finding meaning in coincidence because we desperately want not to be alone? Maybe the truth lies somewhere in the quiet spaces between certainty and wonder, in the recognition that the universe is far stranger and more beautiful than our textbooks suggest, in the understanding that consciousness reaching out to consciousness, across the vast darkness between stars, is the most miraculous thing of all. Tonight, as you drift towards sleep, remember that we live in a universe where impossible things happen every day, where objects from other star systems carry messages we're only beginning to understand, where ancient myths and modern science whisper the same truth. We are not alone. The signals continue. The mystery deepens, and somewhere in the cosmic dark, intelligence watches and waits with patience that spans geological ages.